Hello everyone, welcome back to the another session in Design and Analysis of Algorithms. Topic name is 0 by 1 Knapsack problem. This topic you'll find in third unit as topic number 4. The topics of this video, the contents of this video is, we'll be going to talk about what is 0 by 1 Knapsack problem and we'll apply dynamic programming approach. Let's get started to understand what is 0 by 1 Knapsack problem. So basically, a knapsack is what? It's a container or it is a bag. So in this bag, we wanted to place some items where, keeping in the mind the constraints or two, which is always the profit should be maximum. When you place the set of objects in this bag, the sum of all the profits of the item should be maximum. And the second is, the weight of all the items should not exceed the capacity of the bag. So we'll keep in the mind these two things and we'll find the solution for the problem. The solution is what? A solution to the knapsack problem can be obtained by making a sequence of decisions on the variables x1, x2 up to xn. So these are what the items what I wanted to place in the knapsack or in the container. So what I'm going to do is, as far as dynamic programming approach is considered, we will be going to take a sequence of decisions. That means, can I place x1 only, or can I place x1 and x2? Can I place x1, x2, x3? So we will be going to take a sequence of decisions. All these decisions are to be in line with maximum profit and not exceeding the capacity. A decision on variable xi involves determining which of the values 0 or 1 is to be assigned to it. That means we cannot place the item which is half, the way how we were done in greedy method. In greedy method, 0 by 1 knapsack problem is fractional knapsack problem. To make this capacity in the greedy method, we were taken even fractional part of the item. But whereas in the 0 by 1 knapsack problem, when you are applying dynamic programming, you cannot do fractional part. You have only the way of keeping the item, or you are not keeping the item into the container. That's it. That's what we are representing it with 0 by 1. That means 0 or 1. Item can be placed, item may not be placed. Let us assume that decisions on the xi are made in the order xn, xn minus 1, x1. So in stage wise, we'll take a decision. Following a decision on xn, we may be in one of two possible states. Capacity remaining in the knapsack is m and no profit has occurred. Or the capacity remaining is m minus wn and a profit of pn has occurred. Now, we'll take an example to place in the knapsack. The placing items are x1, x2, x3. These are what the items what I wanted to place in the container. Now my container or my knapsack, the bag capacity is m equal to 6. Now we were given with the profit and the weight. Profit should be maximum. Bag capacity should, after you place the items, bag capacity should not be exceed. So we will be keeping in the mind these two things and we'll get the solution for the problem using dynamic programming approach. Now let us think first of all what the way we will place the items. Now, so as I have the first item, think whether I can place x1 item into this bag. If I place x1 item inside the bag, what is the profit? If I place x1, I'll get the profit which is 1 and the weight is 2. So the total capacity of bag is 6. I am utilizing only 2. So still 4 capacity is left. 6 minus 2. 6 is what? M. 2 is what? Weight of particular item. That means Wi. So M is 6, Wi is 2 and still 4 weight I can utilize for the next object. So I am placing x1 in the container. Now, so as you have this 4, now again go back for x2. So when you have x2, think about to place x1 and x2 inside of the bag. So already I place x1. Now, do you have any chance to place x2? Think about it. So that's what I'm writing the combinations. The first combination is no item is placed in the bag. The next is what? 0, 0, 1. That means third object is placed. This is what third object, x1, x2, x3. And second object is placed. And second and third is placed. One only the first is placed. So likewise, as I have n value is 3, how many combinations I'll get? 8 combinations I'll get. That means 2 cube combinations. 3 is your n value. That means 2 power n combinations will get. That is the time complexity is big O of 2 power n. So this is what the complexity placing of item inside of the container with these 3 size, right? Now we will apply dynamic programming. Half the way we will make items inside of the bag. So now I am taking some example that also we'll see. Let us suppose the same example. We'll go quickly to, we'll make all sets for each stage. That is the first stage, S0 I'm indicating with. So in the S0, 0 comma 0, that is no item inside of the bag, that is no profit, no weight. Now consider the first object into inside of your bag, that is S1 of 0 is equal to, what is the profit of first item? 1. What is the weight of first item? 2. That 1 comma 2 is a set. Now merge these two sets. Now that set is S1. S1 is equal to 0 comma 0 and 1 comma 2. That means first object is not included, first object is included. Now again S1 dash is equal to, after you place first object, now you can place second object too. Second object is what? Profit and weight. Second object is 2 comma profit and weight, 2 comma 3. And this is what? Addition of both. That means 2 plus 1 is 3. 3 plus 2 is 5. This is the set. Yes, 1 dash set is 2 comma 3, 3 comma 5. Now S2 set is equal to merging of these two. S1 set, S1 dash set, merging of these two. Now that is 0 comma 0, 1 comma 2, my first object is placed, 2 comma 3, my second object is placed, 3 comma 5, I placed 2 objects. This is my S2. Okay, now we'll place third object. Third object, if I place the third object, then it is S1 of 2 is equal to, third object is what? 5 comma 4. That is 5 comma 4, 6 comma 6, 7 comma 7, 8 comma 9. So this is your third object and adding of these values to the existing. So we'll get this. Now, so look at this, all these are P comma W values. So bag capacity is what? 8. So this is going beyond of bag capacity. That's what I'm ignoring the value, or I'm cutting the value from the set. Now S3 set is equal to 0 comma 0. No item is in the bag. 1 comma 2. First item is in the bag. 2 comma 3. Second item is in the bag. 3 comma 5. Both the items are in the bag. 5 comma 4. Third item is in the bag. 6 comma 6. Third item and first item is in the bag. And 7 comma 7. Now third item and the second item is in the bag. And 8 comma 9. So I told you 8 comma 9 should get ignored, because as it is the going beyond of that capacity, I'm not going to take that. Now the above is the set 3, where if you look the set 3, observe this profit and weights. Profit and weight. Profit and weight. Here look at this. Profit increases, weight also increases. Here it is 0 initially, now it got 1. So profit increases. Proportionally weight is increasing. Profit is increasing, weight is increasing. Profit is increasing, weight is increasing. Now see here, profit is increasing but weight is getting decreased. That's why the order pair are wrong. So we have to discard, and even so we will discard the smaller profit, which is 3 comma 5. We have now 6 order pairs. Those 6 order pairs are what? 0 comma 0, 1 comma 2, 2 comma 3, 5 comma 4, 6 comma 6 and 7 comma 7. Cutting of this 3 comma 5 is called as dominance rule. So with the dominance rule, the values order pairs which is not correct, that we will cut from the sets. Now the values order pairs which are 0 comma 0, 1 comma 2, 2 comma 3, 5, 4, 6, 6, 7, 7. Now what we have to do, add the other item. Now what other item? The last item I am going to add as 6 comma 5. Now again fourth item and the first item, 6 plus 1 7, 5 plus 2 7. The same, 6 plus 2 is 8, 5 plus 3 is 8, 6 plus 5 is 11, 5 plus 4 is 9, 6 plus 6 is 12, 5 plus 6 is 11, and 6 plus 7 is 13, 12. So these are what the values what we will get from the set, correct? Now very interestingly, whichever item is going beyond of the back capacity, that all will get cancelled, will not take that values. So finally our S4 set is what? Our S4 set is equal to 0 comma 0, 1 comma 2, 2 comma 3, 5 comma 4, and so look at this. So here it is 6 comma 5, right? 6 comma 5 means what? Your profit is high but weight is low. So what item we will be ignoring? 6 comma 6 item we will be cutting out of the picture. So now 5 comma 4, next 6 comma 6 we cut it, and 6 comma 5 and 7 comma 7 and 8 comma 8. So these are what the sets of the these are what the pairs of the last set. So once after you got the last set, now you should know what items are going to be placed in the container. That is maximum profit you gain for the last set. That means 8 comma 8 is belongs to S4, but 8 comma 8 pair you cannot see in the S3. So it senses that X4 item is included, not X3. Correct? Now when you place X4 item, then what is the bag capacity and what is the profit of the bag? After you place X4, that is 2 comma 3. Now let's see whether 2 comma 3 pair is there in the any other set. 2 comma 3 pair is belongs to S3. But 2 comma 3 is not belongs to S2. That means X3 item is not placed. And 2 comma 3 belongs to S2. But 2 comma 3 not belongs to S1. That means X2 is included. When X2 is included, 2 minus 2, 3 minus 3, which is 0 comma 0. So bag capacity is equipped, or we utilize it completely with the X4 object and with the X2 object. So finally, out of these 4 items, what items we were placed, x4 item and x2 item. So this is what 0 by 1 knapsack problem, and I have explained you sets method and tabulation method and using dynamic programming. These are what sequence of decisions to place the item inside of the bag. Thank you all.